Good afternoon. Today we're learning all about earthquakes. So what is an earthquake? Well, in order to explain it, you'd have to start talking about the Earth. The Earth has 4 layers. The crust, which is the bit on the top, which is the bit we're all standing on or sitting on. This is the outermost layer. The land we stand on is not just one solid piece. It's made of many pieces called plates. These plates fit together like puzzle pieces. The mantle, the widest part, it's extremely hot and it consists of semi-molten magma. That's lava that's underground. When lava is underground, we call it magma. When lava boils up out and explodes out of the surface in a volcano or in the middle of an earthquake, then it could be called lava. The outer core, this area is made of iron and nickel. It's very hot. And the inner core, this is the warmest layer. Temperatures can reach 5,500 degrees Celsius. So if you think that's 55 times the boiling point of water, that's pretty incredible. The continents, here are the continents. Now, I know you know all their names. We've talked about their names in the past few weeks. I'm not going to talk about their names today, but I'm going to show you them. There they are. And the continents are all on plates. The plates are what the continents sit on, and they, over the years, have moved. The Earth's surface is called the crust. It's made up of different rocky sections called tectonic plates. This map shows where the plates are. Tectonic plates can move about on the softer mantle underneath, so they don't stay still, they move about. We don't often feel this though. If we could slide South America towards Africa, do you think the two land masses would fit together like a jigsaw puzzle? If you have a look at South America, and here it is, coming across here, fitting to the side of Africa there, can you see how once, years ago, they actually fitted together? I want to tell you about this man, and his name is Alfred Wegener. In 1910, a German scientist called Alfred Wegener was the first to study the idea that the continents might have once been a single landmass. However, it wasn't until 20 years after Wegener died that geologists realized he was right. The continents and ocean floors really do float on moving rock plates and have been moving for many millions of years. Wegener came up with some very convincing evidence to support this idea. He looked at where different fossils were found and was able to piece the continents back together into one landmass. So he looked at ancient fossils and thought, if I found it on this continent, I can look at another one, and if I found a similar one, they were once one landmass, they were once close together. And this is the first continent. All the Earth was one large continent 250 million years ago, and then it gradually started to split. This was called Pangea, and it gradually started to split into different land masses. The names aren't important. The fact that it's splitting over many millions of years is what's really important here. This is the Jurassic period. You might notice it from the dinosaurs. 145 million years ago, the continents we know today were still to become visible. And now, later on, 65 million years ago, we can start to see what the continents look like today, and there the continents are in the present day. So originally from that one landmass, they then split up. And they're the Earth's plates. You can see the red lines are the points between the plates. The Earth's plates are always moving. They move so slowly that we usually can't feel it. The edges of plates are called faults. Faults can rub together, push towards each other, or pull away from each other, and this is where you get an earthquake, when the two parts of plates push together. How the continents are formed. Over 250 million years, the movement of plates has created the land masses we recognize. So here are the continents now as they look today, and they are still moving. They don't move very far, they only move about 10 centimeters a year. But we can see South America is moving towards North America. If I draw that with a pen, there, it's moving in that direction. And we can see North America is moving away from Europe. That's going in that direction. And we can see Australasia is moving towards Asia. It's going in that direction. So where do earthquakes occur? They occur on the fault lines between plates, which is why we don't get them in this country, because we are in the centre of a plate. We're not near a fault line. This is a very famous fault line. It's called the Ring of Fire, and you can see that it's around these plates, and this area is known for being really active with earthquakes and volcanoes. Now, where the fault lines collide, you would have the potential for an earthquake when the plates move towards each other. There are two main ways to measure the power of an earthquake. We have this machine, and it's basically a little needle that goes over a piece of paper, and as the ground shakes, the needle shakes on the piece of paper. These machines are called seismographs. They measure the power of an earthquake at its epicenter, at the middle of it, on a scale called the Richter scale. Another measure is the Mercalli scale, and this is based on people's observations during an earthquake. You can see here that on the Mercalli scale, the severity of an earthquake is measured from 1 to 12. On the Richter scale, I believe it's 0 to 10, and it's not very often that it goes above a 9. So now you know all about earthquakes. I'm going to ask you to have a read of the piece of paper that I've sent you, and I'm going to ask you to fill in as much information as you possibly can. Read the sheet well and fill in everything that you know about earthquakes on the sheet.